Finding a critical region for a one-tailed hypothesis test. We know it's one-tailed because the alternate hypothesis is just probability is greater than 0.35. Because it's greater than, we're looking at the upper value, because we're saying, okay, well there's a high number of values, which would mean that the probability is greater than 0.35, greater than the null. So we're looking at the upper end. And it's a 5% level of significance, so we want the probability to be greater than 0.95. So we do our table, and we're trying to find the probability of x being less than or equal to a value is the first value greater than 0.95. So we want to do binomial cumulative distribution. So we're going to go setup, in fact menu 7, and we want to go down a page, binomial cumulative distribution. We're going to use a list function so that we can see several different values at once. And we've got 6 in total, and we're looking at the upper end, so probably 2, 3, 4, 5. We don't need to go as far as 6 because we know the probability of 6 is going to be equal to 1. Then we press equals. N is the total number of trials, which in this case is 6. And P is the probability from our null hypothesis, which is 0.35. Press equals and equals again. And then that gives us the probability of x being less than or equal to 2. There, x being less than or equal to 3, etc., etc. And then we can use this to say, okay, well, what's the probability of x being above 5 or above 4 by doing 1 minus these values? So now we're looking at the value probability of it being above these values, because that's what we're interested in, because it's the upper limit we're looking at. So we want this value to be as close as possible, but below the first value below 0.05. The reason it's 0.05 is because it's 5%. So we want the probability of this thing happening to be less than 5%. That's what a 5% level of significance means. So that's the first value that's less than 0.05, because that was greater than 0.05. So this is the one we're interested in, and its probability of x being less than or equal to 4 is 0.9776. So if x is not less than or equal to 4, what is it? Well, it must be greater than or equal to 5. So that gives us the probability of x being greater than or equal to 5, which is the first value, which is less than 0.05. So therefore that is our critical value, and we multiply by 10 to get the actual significance. So this is looking at the critical regions for a two-tailed hypothesis test. So we know it's two-tailed because the alternate hypothesis is that p is not equal to 0.25. Okay, so before we've looked at the alternate is either p is greater or p is less than, so we know which side we're looking at. If it's two-tailed, we've got to look at both. We look at both ends. We look at the critical region at the bottom and the critical region at the top. it's a 2% significant level. Okay, because it's two-tailed, we're going to split that 2% into 1% at either end, and the question specifies you want to get as close, each end should be as close as possible to 0.01. Okay, so first of all look at the lower end. So exactly the same principle, you're looking for what x value, and the probability of x being less than or equal to this value is as close to 0.01 as possible. And then at the top end you'll be looking for the probability of x being greater than or equal to x, also being as close to 0.01 as possible. We'll look at that one in a second. So n is 40 trials. We use the null hypothesis here, so probability is 0.025. So we want to find the value which probability of x being less than or equal to is roughly equal to 0.01, the closest value to 0.01 for this two-tailed hypothesis. So we want to go menu 7. Again, it's a binomial cumulative distribution, so we press down arrow and number 1, and we want to use a list function so we can use several at once. We've got 40 in total and our probability is 0.25. So we're looking at the lower values. It can be quite difficult to know, but we can just try a few and see where that comes out at. Oh, got one too many there. Let's change that to a 5. Right, that will probably be far enough. The number of trials is 40, and the probability from the null hypothesis is 0.25. Equals and equals. And some very small numbers, some very small numbers. Okay, and so these are our probabilities. So probability of there being less than or equal to 6 is 0.09, that's almost 10%. So we're looking for the nearest answer to 1%. So these are going to be our two that we're most interested in. Note, if we highlight the values with the keys, as in using the arrows, you can see more and more values. So we'll write those two down and then look which one of those is closest to 0.01. That's a critical value. It's got to be closest to 0.01 because we split that 2% either way. Okay, I just corrected a typo there on that. So now what we're looking at is which one of these is closest to 0.01, okay, closest to 1%, and that is 0.0053 away, and this one is 0.00604 away from 0.01. So our closest one is this boundary, so our critical value at the bottom is x equals 3. Okay, we then need to find the critical value at the top, and that's going to be, we're looking for the probability of x being greater than or equal to the number is as close to 0.01 as possible. So therefore, how we actually do it on our calculator, because remember it doesn't do greater than or equal to, it does less than or equal to. So we're saying we want to find the probability of x being less than or equal to a value is the closest value to 0.99, because then being above that must be equal to 0.01. I guess we'd actually could say that this is y, okay, it's a different value to, because that's going to be 1 greater than it. Okay, so now we're going to use our calculator again. Okay, so we're trying to find the critical region at the upper end, as in the higher value for our data. So we go statistics, and we're going to do a list again. And we've got 40 in total, the probability of the null hypothesis is 0.25. So we need to find, okay, well, above what value or up to what value is it 0.99? It's really difficult. You don't really have a way of knowing. You could test a few values, but I think quite an effective way is we use the list and we just space our values out a bit. And it's 40 values and the null hypothesis is 0.25. And this just allows us to hone in on roughly where the value we're interested in is. Okay, so we can see that less than or equal to 10 is way down. Bear in mind, we want this value to be 0.99. Okay, so it's somewhere between 15 and 20 that this critical value happens. So then let's change our parameters to 15 to 20. So 15, 16, 17, 18, 19, 20. And it's still 40 and it's 0.25. And then we're looking for the one which is closest to 0.99 because you want it above this value to be 0.1%. Okay, so then it's basically going to be between those two and we work out which is closer to 0.99.
So we know it's going to be between these two, and we just do the bigger one minus 0.99 or 0.99 minus the smaller one to find out the difference, and the differences we'll just work out now. So we've worked out how far each of these numbers are from 0.99, and this one here is closer. So we know that the one that's closest to 0.99 is probability of x being less than or equal to 16. So therefore, the critical value we want, so it's probability of x being greater than or equal to 17. So 17 is our critical value at the top. So our critical regions x is less than or equal to 3, and at the top x is greater than or equal to 17, and the top it can be is 40. We could put a 0 on here, either is fine. Okay, so those are our critical regions. Any values within those regions would lead us to reject our null hypothesis. And note, each one, how we established it was just the closest value to 0.01. Okay, in this case it was the closest value to 0.01. The actual significance, it would be, we need to work out the significance in this one by doing 1 minus 0.988436, which gives us, so 1 minus that, 0.988436 is 0.01156114, so it's 0.01156114 plus the significance from the bottom, 0.00469568. Add those two together and it gives us which goes to 1.63%. Okay, and an important thing to note here, so it doesn't actually matter that this limit, the critical value at the top was slightly over the 1%, because the question specified we just want to get as close as possible to 0.01. Okay, if it didn't specify as close as possible, then we'd have to look for both limit just under 0.01.